record. Should be on. Can you hear me?
Yep, I can still hear you.
All good? Okay. All right. Let me go ahead. All right. Cool. I should be on. All right, guys. Thanks for joining in, and thanks for your patience. I was MIA for a while due to personal reasons, but I am back, and you guys are jumping straight into your first routing protocol, OSPF, right? And so we're going to be going over, right, the concepts. We're not diving deep into the details just yet. There's some prerequisites we need to take care of, right, before we jump into the particulars of OSPF. Because it's very complex, right? But for the CCNA, you guys need to know it, right? You guys need to understand it at a CCNA level, right? So let's go ahead and jump on it. As always, if you guys have any questions, please feel free to stop me. Please feel free to, I got my eye on the participants, so stop me, yell, scream, bark, whatever you got to do, okay? So let's go ahead and get started, right? So we're looking at the OSI model, right? Or the TCP/IP stack, which is on the right, right? We are still operating, right, at layer 3, okay? Right? And so you guys conquered layer 1. You guys conquered confidently layer 2. We're going to do some review on layer 2 later, right? But you guys confidently, with me, got over layer 2, right? Now we're moving on to layer 3, okay? So this is part of the prerequisites that we need to take care and make sure you guys know the difference, right? So the term routing protocol and routed protocol or routable protocol, right, means different things, okay? Routing protocol, right, messages, rules, algorithms, neighborships, et cetera, right? It's a way that these routers, right, learn routes, right? So they can pass traffic, right? They're doing the work for you by becoming friends in the most simplest of terms, right? They become friends, they become neighbors, right? And they do the work for you, right? By passing traffic from the source to the destination, right? Routing protocol examples. eGRIP, right? Something I'm studying now for my CCIE, OSPF, and BGP, routing protocols, okay? Routed protocol, right? Routing, action, routed protocol, or routable protocol, right? What's being processed, right? Right? To keep it simple, you can think about what's being processed, right? What's being seen at layer 3? IP addresses. That's the difference. Routing protocol is what does the action. Routed protocol is what's being carried. IPv4, IP addresses, IPv6, okay? You can read all this, you know, all the stuff that's here, but I want to keep it simple for you guys, okay? All right, and of course, to note, last but not least, at the bottom, I do want to touch on that, right? Path selection, right? Sometimes referred to as part of the job of the routing protocol, right? In which the routing protocol chooses the best route, right? That still falls under what eGRIP, OSPF, and BGP is going to do, okay? So when you hear path selection, do not associate it with routed protocol or routable protocol, okay? All right, so we talked about, let me go actually stand up for this. We talked about at layer 2 that a switch, which typically functions out of the box at layer 2, has 3 major functions, okay? Right? A router has the same thing at layer 3. It has 4 major functions. It probably can do other things, but it has 4 major functions, right? And I'm sorry, let me correct myself. Routing protocols have 4 major functions, okay? So if you're using routing protocol, at the minimum, these 4 things are what it needs to do, right? Learn routing information about IP subnets from neighboring routers, right? That's 1. 2, advertise. However it advertised, right? Don't get too deep into the process just yet. We're not there, right? Just remember this. Advertise routing information about subnets to other routers, to its neighbors, okay? That's number 2. 3, if more than one possible route exists to reach one subnet, pick the best route based on a metric, and we'll go over that in a second, okay? All right? So process of elimination, right? You guys seen the process of elimination before at layer 2 when we talk about spanning tree, okay? When we talk about choosing the root bridge, right? So some of this should be similar. You guys should remember when I told you guys, you need to learn layer 2 first because it gives you kind of, right? A kind of a practice round, right? I play video games, right? It gives you a practice round to get ready for the real thing, which is, of course, routers, right? 4, right? If a network topology changes, right? React by advertising that some routes have failed and pick a new currently best route, right? Convergence, that's what that is, okay? These are the 4 functions that a routing protocol, not a router, I wanted to make sure I correct myself, a routing protocol has to fulfill. I don't care if it's ISIS, I don't care if it's RIP, I don't care if it's eGRIP, I don't care if it's BGP. These are the 4 things it has to do. And I'm going to tell you guys, right? If you understand these 4, learning any routing protocol, right? BGP, OSPF, eGRIP, it's going to be easy. Okay? So, sorry guys, that's my dog. So with that being said, give me 1 second, guys. Right? So I'm back, guys. So sorry, I got friends coming in. So, right? So we take care, you guys understand the routing protocol functions, those 4 major functions, you'll be able to understand, right? You'll be able to learn and be open to learn all the other particulars within each routing protocol. Okay? Let's keep going, right? So we talked about the 4 major functions, right, that a routing protocol has to fulfill. Let's go ahead and take a look at this, right? So they're numbered 1, 2, and 3, right? Let's follow 1, 2, and 3, right? So we got R2. We start at R2, right? It has neighbors. It has R1 has a neighbor. It has R3 has a neighbor, okay? R2 says, oh, I have a route to 172.16.3.0/24, okay? It's going to go ahead and share that information with R1. That fulfills one of the routing protocol functions, right? Right? And it's also going to share routing information with R3, right? Taking care of one of those functions, right? Now R3, right, is going to do the same thing, right? It's going to advertise routing information, right? And it's learning routing information. That's taking care of one of the 4 major functions, 1 and 2, learning routing information and advertising routing information, okay? Right? And so 3, right? Let's go ahead and look at R1. I'll use the route out of gigabit 0/0/0 because it has the lower metric. So it has 2 ways, right, to get to 172.16.3.0/24, but it chose the best route that takes care of number 3 of the routing protocol functions, okay, right? Number 4, of course, it'll work in the background, and we'll get, that's particular to how it works to different subnets, okay? But this is how it works, how it looks, okay? So give me 1 second. Sorry about that, right? So you guys saw that. Let's go ahead and keep going, okay? So a couple other things, right, that we need to understand before we learn OSPF, right? The difference between IGP and EGP, okay? IGP, routing protocol that is designed and intended for use inside of a single autonomous system, okay? I'll show you a diagram of how that looks, okay? EGP, there's only one, right? A routing protocol that was designed and intended for use between different autonomous systems, right? That's how the internet functions, right? You guys probably know I'm talking about BGP. There's only one, okay? All right, let's keep going. Okay, so as you guys can see, right? If we look at autonomous system, right? ASN means autonomous system network, right? If we look at ASN 100, right? That's using egress. That's a IGP, right? That's an interior routing protocol, right? That's being used, interior gateway protocol, I'm sorry, that's being used within an autonomous system, right? And just as the definition says, each IGP can be used in one autonomous system, right? EGP is responsible for flowing that communication between different autonomous systems. So you see BGP connects multiple autonomous systems, right? So hopefully this makes sense, and I'm trying to make it as simple as possible because I know, right? I'm sure you guys know as well, right? You can go into the weeds, which each and every one of these protocols that we see on this diagram. But I want you guys to learn the fundamentals first, right? So BGP, transporting between different autonomous systems. IGP is takes care of only one autonomous system, traffic within autonomous system, all right? Let's keep going. Whoops. Another prerequisite you guys have to understand before we go ahead and dive into OSPF, right? The different types of dynamic routing protocols, okay? So we have distance vector, right? We have advanced distance vector, right, egress, and we have link state, OSPF, okay? Keep that, do your own research, but this is, when it's marked key topic in that book, that means you guys need to understand it for the exam, okay? Let's keep rolling. All right, quick note, of course, whenever you're reading the book and everything that we're going over, it's referencing OSPF version 2, all right? Now, metrics, okay? So each routing protocol, right, they have their own individual metrics on how they scale or weigh how valuable a route is, okay? RIP version 2, hop count, right? OSPF, cost, right? egress, calculation based on bandwidth and delay, okay? So keep this in mind, right? Each routing protocol doesn't have the same metrics, okay? Along with administrative distance, right? And we'll get to that shortly, right? So let's go ahead and take a look at an example of metrics. So 2 networks, the same, 3 routers, okay? So RIP goes by hop count, okay? So if my destination, right? If my destination, however long it takes to get there, whoever has the shortest hop count, that's going to be the route that I install in my routing information base, AKA my router. With OSPF, right? Because I'm going based off of cost, right? Whoever has the least cost, I'm going to go ahead and install that in my routing information base. And as you can see in the diagram, right? As you can see in the diagram, you see between routers B and A, it's using a serial link, very slow, right? Imagine if you're trying to download YouTube video of watching One Piece, right? It's going to take a very long time. But versus, right? And we're talking, right? And the bandwidth is in kilobits, right? Gig interfaces, right? OSPF is going to choose the faster links, right? Versus RIP using just a hop count, hey, because it's shorter, right? Even though it's shorter, still, doesn't have high speeds, okay? So this is what I mean as far as metrics are different, okay, within different routing protocols, all right? Let's keep going, all right? And this is just a table of comparing the IGP, so I'm not gonna go over this, right? You guys can read this in your book, right? I will go over administrative distance, right? Because this is another prerequisite you guys have to understand. If you guys have been labbing up, as you guys should know what this is, right? But I'm gonna go ahead and go over it, all right? So what is administrative distance, right? How do I summarize, right? The word trust comes up, right? So if we're looking at the numbers, right? With the numbers to the right, and of course the routing type on the type of route on the left, right? It tells us, you know, how much we should trust something and which one is more trustworthy than the other, right? The lowest number tells us it's more trustworthy than others, right? So if I look at a connected route type, right, it's 0. The router is going to trust that more than any other type of route, right? That's it. Simple as that. Not going to get into the weeds using big words. That's it. If you have a lower AD, you'll be trusted than all those other route types that have a higher AD, period. Okay? Since this chapter is about OSPF, right? And I'm actually studying eGRIP for my CCIE, right? OSPF has an AD of 110, right? And eGRIP has an administrative distance of 90, right? So if my Kivia she's working on a router, the same router I'm working on, and she installs a route, right, for a destination network, and I do as well. We go ahead and configure it. My eGRIP route will go ahead and be installed versus her OSPF route. Not because of the metrics, right? But because of the administrative distance, right? My router trusts routes from eGRIP versus OSPF. Okay? All right? Here's some other route types as well, right? But the same applies, right? The lower the administrative distance, right, the more trustworthy it is, right? And the more trustworthy it is, the more that it's more likely to go ahead and get installed in the routing information base, AKA the routing table, right? And I'm going to continue to use routing information base so it gets locked in you guys' heads, right? Whenever you guys, become engineers and get your CCNPs as well, you know that term like the back of your hand, okay? All right? Of course, there's a command you can go ahead and take a look at all the administrative distances, right? And do a show IP route, and you can see those values or what have you, all right? And that's it, right? So we're going to continue to break up these OSPF sections, right? We're going to go very, very slow, okay? We're going to get into the intricacies of and the details of neighborship, OSPF database. We're going to get through all of that, right? But just for good measure, right, because we still have time, we're going to go ahead and configure OSPF, okay? All right? We're going to use the help command, of course, but we're just going to set it up for now because it's the same lab we're going to use to learn all of the fundamentals of OSPF, all right? So whenever we log into a router, and this is all review, we're brought into user mode, right? But my goal is to get into, to make changes on the device. So I need to get to global configuration mode since I'm going to make changes to the entire device, right? But first, I need to go ahead and get into a mode that gives me privilege to get to global configuration mode, right? So I need to go ahead and type enable, right? So if I hit the question mark, right, and all this is review, it tells me turns on privilege command, right? And to do that, I just go ahead and type enable, right? So I go ahead and type enable. Perfect, right? So I'm here, right? All this is review, right? And so I want to enter global configuration mode, and it tells me here, right? I just need to type in configure, right? I could type terminal as well, right? But question mark tells us what options we have with any command, okay? So I'm going to go ahead and type terminal, right? Cool, I'm in, right? So before you guys got here, went ahead and configured the host name and of course the IP address, right? I'm on R1, so the IP address is 6.4.2.1. Let's go ahead and verify. Show IP. It's brief. Perfect, perfect, right? So status, layer 1, right? That's telling me it's up. Protocol, layer 2, meaning it's up. Again, all this is review, right? So, and we have an IP address. So we can go ahead and configure OSPF, okay? I'm gonna go ahead and type router, and let me clear all this out. Give me 1 second. There we go. All right. Type router. I got multiple options. We're focused on OSPF. Okay, I'm gonna go ahead and type that. All right, and it's giving us, hey, what's the process ID? All right, I'm gonna give it 100. All right. We are going to, all right, add the network, all right, meaning the subnet that they both share. I'm going to do the wildcard, right? So it's a /24. I'm going to do an Uno reverse, and I almost forgot because I've been so stuck with egret. I need to put the area, and we'll touch on areas once we go deeper in this chapter, all right? I'm going to go ahead and put that backbone, which is area 0, okay? I'm going to save that, all right? Just for us to have a little fun and to make you guys a little bit curious, we're going to see what's happening in the background. Okay. Let Wireshark boot up. There we go. Perfect. All right. So we see hello packet, right, from OSPF being sent. We'll talk about hellos in the future. All right. Okay. Go ahead and set that up. 4.2.0. Okay. Set that area 0. Boom. Okay. All right. Perfect. Right. A lot of things are happening, right, that I'm not going to talk about just yet, right, because we're going to get to that, right. I just wanted to let you guys know on how this looks, right. And as we can see, right, an adjacency is happening, right. Now, R2 has a neighbor, 6.4.2.1, which is, of course, is on R1, right. And now a routing protocol is working, right, and it can go ahead and transfer data between each other, right? Right, for different subnets that it'll share, that it knows about, et cetera, et cetera. And on that note, we're going to end, right? So we're on chapter 19. Read chapter 19. If you do not have the CCNA book, volume 1, please reach out to me, all right? OSPF is nothing to play with, right? One of my favorite topics, right? Alongside of eGrip and spanning tree, okay? But we're gonna take this very, very slowly, all right? So, okay, Makibi, I saw it. Will do. I'll go ahead and shoot you a PM. All right, guys. Well, on that note, you guys have a great day, and this will be posted shortly.